Okay, listen, this is just a quick explanation of a scooter controller, or e-bike controller, motorcycle controller, and what it takes to get one of them to work on your vehicle. They look really complicated, and you see all this mess of wiring, and you're scared, but there's really only a handful of wires here that matter. A lot of it you don't have to have. You can plug it in later as you learn what you're doing, but let's start with this bicycle controller, and I'll show you what it's going to take to make this guy actually spin a motor. So first thing you're going to need is these two right here. They're black and red on this controller. It's not always the same, depends on your controller, but these are critical. That's your battery power and your battery negative. In this case, red is positive, black is negative. You can fuse this red one if you want to, or you can, I don't think I would fuse it, but you could put like a interrupt, a heat interrupt, a breaker, something like that, if you need to. Generally, on a bicycle, there's not much point. You're better off to fuse the charging side. Okay, let's move on. We need the phase wires. Okay, the phase wires are going to also be about the same size as those battery wires because they have to carry that same current. They're green, blue, and yellow. That's almost always true on an AC controller like this. Okay, because here's the motor wiring. See, there's the scooter motor, and it also green, blue, and yellow. Match those together to start with. Just plug yellow to yellow, blue to blue, green to green. There you go. Okay, that's got your motor phases wired, but you've got to explain to the controller where those magnets and coils are. So that's what this plug is on this one. Some bicycle controllers may have it, I don't have one here, but they may have a slightly different type of connector. Anyway, they'll have like this flat type, but it'll be these wire colors: green, blue, yellow, black, red, sometimes a white. Okay, these are your Hall sensors for the motor. They need to be plugged in the same way. Okay, the colors need to match because you need the sensors to match, and obviously you need the power and the battery negative. Now, if you don't have a white wire or a gray wire on your motor lead, don't worry about it. That means you don't have a temperature sensor in the motor. That's not critical. Okay, so now we've got our Hall sensor wired, right? We've got our leads wired, and we've got power to the controller. But we need to turn the controller on, and that's what, in this case, that's what this guy is here. Coming out of this, and you'll have to test it, but coming out of this is going to be battery voltage. And what this needs to do is go into a display screen or a key switch, or you could just short it to the return. In this case, the return is this yellow wire. That yellow wire, once it gets battery voltage on it, it will enable the controller and allow it to spin the motor. But of course, now you need to tell it to spin, so you need a throttle wire. That's this guy here. Now, on a bicycle controller, it's not always red, green, and black. Sometimes it's red, green, and blue, which can be confusing because you'll also have a Hall sensor for your pedal assist sensor. If you mix them up, it won't hurt anything, okay? They both run on 5-volt reference. And they both work the same way. It's just you've got to make sure the throttle is connected to the throttle for it to do anything. But in this case, this is the throttle wire. Red is your 5-volt going to your throttle. Let's see, I've got a throttle here we can show. It's actually got the same exact wires. Right there is my throttle wires. They're also red, green, and black. Okay, so they would plug together like so. You just need to make sure, on this one, you need to make sure that they match. So if you're confused by which one is your reference, you just measure it. It's going to be 5 volts. The black is going to be your battery negative, and in this case, green is your signal return. Sometimes it can be gray, sometimes white, sometimes even blue. The same as this one. See, this one's wired differently. It's got the signal return out on one side. It's common to have to repin stuff, okay? In this case, this Hall sensor is actually pedal assist. Okay, anyway, that's it. Now this is plugged into a throttle, motor's wired, you've turned it on, you can drive. Now, if the battery or if the motor is janky, or it's going the wrong direction, what you're going to do is turn it off. You're going to elevate that driven wheel, that hub motor, or that whatever kind of motor you're using. You should get it off the ground so that because when you do this next step, it will start driving on its own for a bit. What you're going to do in this controller, you've got two single connectors here. They're not always white. Sometimes they're a different color. So I'll bring another controller here. On this one, same thing except they're green. So it's the same deal. These two little single pin connectors. Well, this is a dual pin connector, but it's a single wire. You plug those together with it off. You turn your key on, you turn your display on, or you short your wire. The motor's going to automatically start spinning, and it's going to self-learn, and that should clean up any janky activity. But it may still be going the wrong way. Turn it off and repeat the process. It'll reverse. Okay, each time you replug this, turn it on, it's going to go a different direction. All right. Sometimes you don't have this on your controller. Okay, bicycle controllers usually do, but a lot of times larger controllers, scooter controllers like this one, it doesn't have any provision to do that, right? Now these big ones here, that's not a problem. You can program all of that with a computer. But yeah, these guys here, in fact, these usually come with where they'll, especially if you connect these to a hub motor, they'll almost always spin it the wrong way. Every time I've ever seen any of these larger ones. That's not usually a big deal, even if you can't reprogram them, because you can swap these phase wires to the motor. So rather than going blue, green, yellow, you can go blue, yellow, and yellow, blue, and then keep the green together. Or it just depends on what works. You may have to swap green and blue, and usually you need to also swap the corresponding hall wires. So if you swapped your green and your blue on your motor phase, do it on the hall phase too. And most of the time that will correct the wrong direction. It depends on the motor and it depends on the controller. Okay, we'll move on really quickly. Because that covers everything. That covers motorcycles, that covers scooters. Like I said, wire colors, you've got to rely on any information they've given you, if you had any. Like for example, in this case, looks like a mess, doesn't it? But it's the same deal, okay? It's just gonna be throttle, and it's just gonna be, see, it's just gonna be right here is on this one, your phases go into these screws. Your battery power goes into those screws. This is actually your Hall sensors out here on its own. This is alarm system. We don't need any of that, right? So all we need to do is get this thing to turn on and have a throttle action. And of course, these wire colors, they don't make any sense, right? But going by the website, this is a QS. So go to their website, you look up their colors, and that's how I figured out throttle, and then power was this orange one. But it works exactly the same as the bicycle. Here, for example, here's a huge Kelly controller. It's like a 500 amp Kelly controller, and you think, oh, it's probably really complicated. No, it's the same thing. See that? There's your hall wire plug. You screw your phases in here. You screw your power leads in here, and this orange wire is your power on, and then of course your throttle. There's a couple other functions I added. This is a forward reverse switch. This is a brake. This is a brake on off. This just disables the controller from moving if you pull the brakes. That's all. Don't really need it on this controller because this one has regen, but that's another. Now, and the other thing you're going to see on these larger controllers is usually, like for example, this one has this. This is a diagnostic connector. You need their special adapter. You plug this into a USB port, download their software. You can program certain functions. Most of these type do that. When they're these QS motors, when they're reasonably expensive, then they should have some kind of ability to do that. This is a FAR driver, and of course it has a really easy diagnostic process. It's really easy to set that up. And it's even the same, exactly the same deal as far as the wiring, of course. It even uses similar colors. Orange, power, gray is the brake. In this case, I've got a blue. That's a signal return for your speed. If you need a speed display. Throttle. There's my little hall. There's my little hall plug right there. That's it. Now this is a big one that has no ability to change it that I could discover. There's no diagnostic terminal. It's a purpose-built thing. It works, but you know, you can see it's the same thing. All you got to do is remember that you need the phases and the hall wires to work. You need the ability to turn it on. In this case, again, it's an orange wire. You know, don't rely on that, but most of the times, you know, it's on these bigger ones, it's probably orange. I think this is my throttle. Again, this one had an alarm system, completely useless for this application. The rest of these, I don't remember. May have had some speed sensor controls on them. Anyway, yeah, that's it. That's all you need to know to get them working. I guess the only thing I could say after that would be a small note of caution is the first time you've wired a controller and you plug these two guys into your battery, you're going to get a pretty significant pop because all the capacitors in here are dead. And when you first hit it to that battery, it's going to boom. So that's why you may want some kind of some of them demand it, some of them require it. Like for example, this one has I'm trying to think what you call it. Basically, when you first load up the capacitors, it doesn't want to surge, so it's got this guy. All right. Now this diode I put on here, that's for regen, but and they usually, sometimes they'll provide it, but sometimes they'll insist that you have some sort of resistor to absorb that load. These bicycle controllers, I've never seen any kind of problem. You know, they pop, they still work, they're fine. You know, it might scare you, but it's not particularly dangerous. These guys here, the more amperage you have, the louder the pop is. It never seems to hurt these. If it bothers you, run a switch the first time. Once you've got the capacitor powered, you can then unplug it and replug it in, and it won't pop again. You know, unless you let it sit until the capacitor bleeds down. That's all I got for you.